Okay, this is notes 4, graphs of functions. Okay, we're going to talk about linear and constant functions, the graphs of basic functions, and definitions of quadratic functions, and then lastly talk about x and y intercepts. So concept 1, linear and constant functions. It says let m be represent real numbers such that m cannot equal 0. Then a function can be written in the following form, mx plus b, which is a linear function, and f of x is equal to b, which is a constant function. Okay, so the important part here is that you know that m represents slope and that b represents y-intercept. Okay, and a linear function and constant functions are two types of linear functions. So when we think of a linear function, it could be any type of line, right? It could be a vertical line going in, a slanted line going the positive direction, a slanted line going in the negative direction, or it could be a horizontal line, okay? These are all different types of linear functions, okay? Here it shows an example here. We have one type of linear function, okay? And then we have another type of linear function. Again, this one is constant because it's only going through one number, and that is the number 3. Constant functions are always horizontal lines. Okay. Remember, we talked a little bit about vertical lines the other day when we talked about the vertical line test. And vertical lines, like let's say we had this as our graph. Okay. The reason why vertical lines are not considered a linear function is it does not pass the vertical line test. Because if I was to draw a vertical line through this, notice how it would cross through every single point on that graph. So this is just a vertical line, not a linear function. Say not a linear function. We'll talk more about those in a different notes. Okay, here are the graphs of some basic functions. I went over them briefly in class. I would just make sure that you memorize the basic shape of each one. The basic shape of each one is going to help you when you are graphing and plotting your own from points. Okay, so for example, we have f of x is equal to x squared. Okay, if I was to ask to plot this onto a graph, they're not going to give me any points to use. Okay, so I'm going to have to pick my own points. When I'm picking my points, the easiest thing I like to do is to make sure I pick 2 negative numbers, a 0, and 2 positive numbers. Okay, so these are my x and these are my y's. And the numbers that I choose, you can choose any numbers. Okay, I'm just choosing these ones because I think they're easier. Okay, so I'm going to choose -4, -2, 0, 2, 4. And then in order to find the corresponding y value, I'm going to plug in these x values into x squared. So I get -4 squared, which is 16, -2 squared, which is 4, 0 squared, which is 0, 2 squared, which is 4, and 4 squared, which is 16. Okay? Which means that I got these points. I have -4 comma 16, that's 1 point. -2 comma 4, that's another point. So I'm going to write these points down here. You don't have to do this, but maybe for the first time it helps to visualize where these points are coming from. And then once I have these points, I am going to plot them on my graph. Okay, when I plot them on my graph, you're going to notice that this graph is not large enough to go up to our highest value, 16. So instead, I'm going to count by twos. So all these grid lines that you see, instead of counting by ones, count by twos. For example, this would be 2, 4, 6, 8, 10, etc. Same up here, 2, 4, 6, 8, etc. And then remember, this way is negative, and this way is negative. Okay, so I'm going to start plotting my points. So I have negative 4, 16. So that would be 2, 4, 6, 8, 10, 12, 14, 16. That's right here. Then I have negative 2, 4, 0, 0, 2, 4, and oops. Sorry, my iPad's a little sensitive. And then 4, 16. Okay. So if I didn't know what the function f of x equals x squared looked like, and I was just to connect the points, it would almost look like I was connecting this in a V, which is not correct. That's a no-no, okay? I know x squared is quadratic, so it has to have that U shape. So when I draw this, I need to make sure that I'm drawing this with a U shape. And of course, that wasn't perfectly done. Let's see, right here. Okay, but here it's a U shape at the bottom right here. Okay, not a V shape. Okay, and that would be my graph. Okay, on the next example, notice that it's the same thing, but now it's a negative x squared. So I'm going to use my same numbers. So these are my x's, these are my y's. Negative 4, negative 2, 0, 2, 4. And what you'll notice is that all the answers are going to be the same, but they're just going to be negative because that negative is not attached to the x squared. For example, negative 4 squared becomes negative 4 squared. Well, negative 4 squared is 16. The other negative makes it negative 16. Then I have negative 2 squared, which is negative 4. Negative 0 squared, which is 0. Negative 2 squared, which is negative 4. And negative 4 squared, which is negative 16. Which means when I'm plotting this graph, 2, 4, 6, 8, 10, 12, 14, 16, you'll notice that it's going to start going in the opposite direction. Okay. So what happened here is that this is still a quadratic, but it's a quadratic going in the opposite direction. Okay, so let's do this one. This is 1 over x. So I'm going to do my points. Here's my x, here's my y. I'm going to choose the same numbers, negative 4, negative 2, 0, 2, 4. And then I'm going to plug in these numbers in for x. So 1 over negative 4, 1 over negative 2, 1 over 0. Well, this is undefined, so we know that point is not going to exist on the graph. 1 over 2 and 1 over 4. Well, looking back up at my graph right here, I know that 1 over x is my reciprocal function. And my reciprocal function looks like it's going in two separate directions. And it makes sense that when I plugged in 0, I got undefined because look, there's no points here at 0. So when I go and graph this, I'm just going to graph those points that happen to fall on the graph. So negative 4, 1, 2, 3, 4. And then notice this time I'm not going by 2s anymore because I don't have to. So I'm just going to go by 1s. And then 2, 1/2. And then 2, 1/2. 4, 1/4. And look at this. I only those 2 points plotted. If I did not know this was the reciprocal function, this would be almost impossible to draw. But since I know that it's the reciprocal function, I know it's going to look something like this. Okay. Okay. Okay, now the next one, I have the absolute value function. So this is the absolute value function. And this is significant because the absolute value bars, these bars right here, they get rid of the negative sign. So every time you plug in a negative number, it gets rid of it. So for example, if you plug in a -5, it's now 5. If you plug in a -6, it's now 6. If you plug in a -10, it's now 10. If you plug in a +10, well, it's still 10 because there's no negative sign to get rid of. Okay? Think of these absolute value bars as little choppers that chop off the negative sign. Okay, so I'm going to use my same numbers. -4, -2, 0, 2, and 4. And I'm going to plug it into my equation. So absolute value of -4 minus 1. Absolute value of -4 is 4. 4 minus 1 is 3. Absolute value of -2 minus 1. Absolute value of -2 is 2. 2 minus 1 is 1. Absolute value of 0 minus 1, well, that's just -1. Absolute value of 2 minus 1 is 1. Absolute value of 4 minus 1 is 3. So I have the following points. I have -4, 3, -2, 1, 0, -1, 2, 1, and 4, 3. So then I plot these points. -4, 3, so 1, 2, 3, 4, 1, 2, 3. Oops, I did it the wrong way. 1, 2, 3, 4. Right here. 3, -2, 1, 0, -1. Okay, 2, 1, and then 4, 3. Okay. Okay, notice. Okay, notice if we didn't know this was the absolute value function, we might be tempted to use a U shape just like the quadratic. But know that the absolute value function is a V shape. So when we draw this, we need to make sure that there is a V shape on either end. And I don't know if I was doing this on all of them. Yes, I am. Okay. Make sure when you're drawing your graph, you are putting arrows on either end because there's no restrictions on this graph. So we don't know how far away it's going on the x's or the y's. So even though we only did a couple points, there's still more points going in either direction, okay? So that's why I do the arrows in either direction. Okay, next concept is talking about a quadratic function. A quadratic function is f of x is equal to ax squared plus bx plus c. And a quadratic function is using that parent function f of x is equal to x squared. So they're going to look like the U shape, either the regular U shape or the upside down U shape. Okay, so it wants us to name the function. So here, this is only equal to a number, so this is a constant function. Okay. This one has an x squared, so it's quadratic. Okay. This only has one x, so it's linear. Okay. This looks like it's a fraction, but really I could simplify this because this is the same as saying 4x over 8 plus 8 over 8, which is equal to 1x over 8, which is equal to 1x over 2 plus 1, which is linear. Here, the x is on the bottom. And again, if we go back up and look at all of our different types, the only one where x was in the denominator was this one, the reciprocal function. So this was a reciprocal function. Okay. This one has an x squared, so it's quadratic. This one only has a number, so it's a constant. This one has x in the denominator, so it's a reciprocal. Okay, this one has an x squared, so it's a quadratic. So again, you have to be able to identify based off what the graphs look like and based off what the parent function of the equations look like. Okay, and it makes it very easy to go through these quickly if you know what you're looking for. Okay, last concept here is finding the x and y intercepts. So it says, given a function defined by y is equal to f of x, the x-intercepts are the real solutions to the equation f of x is equal to 0, and the y-intercept is given by f of 0. Okay, that's good and all, but just remember x-intercepts means y equals 0. Okay, y-intercepts means x equals 0. So when it's saying find the intercepts, that's what we're doing. Okay, so the first one's x-intercepts. So x-intercepts is when y is equal to 0. So let's do that. Well, remember, f of x is just a fancy way of saying y. Okay, so this is 0 is equal to 2x minus 4. And now I'm just going to solve for x. Add 4 to each side, so 4 is equal to 2x. Divide by 2, 2 is equal to x, which means my x-intercept is 2, 0. Okay, then my y-intercept is when x is equal to 0. So then I have y is equal to 2 times 0 minus 4, which means y is equal to negative 4 because this cancels out. So then my y-intercept is 0, negative 4. Well, what's nice about x and y intercepts is that I could plot these 2 points and I'm able to draw my linear equation. Okay, so for example here, I'm going to do my x-intercept first, so 2, 0. And then I'm going to do my y-intercept 0, negative 4. Okay, now that I have those 2 points, I'm able to connect them with a line, and that is my linear equation. Okay, same thing for this one. Here is my x-intercept, that's when y is equal to 0. I know that's a fancy way of saying y. So 0 is equal to negative 5x plus 1. Subtract 1, I get negative 1 is equal to negative 5x. Divide by negative 5. X is equal to positive 1 over 5. Okay, which we know is about 0.2. Okay, so that means my x-intercept is 1/5, 0, or you can write it in decimal 0.2, 0. My y-intercept is when x is equal to 0. So I do y is equal to negative 5 times 0 plus 1. This cancel out, so y is equal to 1. So then I have 0, positive 1. So then I plot those 2 points. 0.20, so it's going to be somewhere over here. 0, positive 1, somewhere over here. Okay, I'm going to connect those 2 dots. wasn't very pretty. There we go. Do my arrows on both ends. And then there's my graph. Well, let's say they already give you a graph. Okay. Well, we know that my x-intercepts is all the points that crosses the x-axis. Okay. And my y-intercepts are all the ones that crosses the y-axis. Okay, so for my x-intercepts, I know it's going to be -2, 2, and 3, which I would write as -2, 0, 2, 0, and 3, 0. Again, these are my x-intercepts. And then my y-intercept would just be at this one point, 6, which I would write 0, 6, and this is my y-intercepts. Okay, same thing over here. Okay, x-intercepts is whatever crosses the x-axis, so that would be right here, and right here. And y-intercept is whatever crosses the y-axis, so right here. Okay, which means I have my x-intercepts as -2, 0, 1, 0, and 4, 0, and my y-intercepts as 0, 4.